Alright, we are good and we are set. Today we'll be learning about equivalent fractions. My name is Miss Gabby. I won't go by that all the time, but for you guys it's very special. We're going to talk about equivalent fractions today. I wanted to give you guys a real-world problem as to why equivalent fractions are needed for anyone and everyone. I'm going to read you this. I'm going to write some key points on the board behind me. Alright, scholars. I have a friend whose birthday is coming up, and they've asked me to make them their favorite birthday cake, funfetti cake. I went to the store and bought everything I needed to bake the cake, but I only have few measuring cups in my cabinet. I have a 1/8 cup, a 2/3 cup, a 1/2 cup, but the recipe calls for 1/4 cup of sugar, 4/6 cup of flour, and 5/10 cup of sprinkles. How will I ever make their cake? Will you scholars help me figure out how to make their cake for them with the measuring cups that I have already? Alright, now we will talk about equivalent fractions. The definition of an equivalent fraction is two or more fractions that are equivalent. They take up the same area or space. We'll be using our fraction circles shortly, and we'll demonstrate with those. Right now, we're doing examples. I'll write them on the board. We're doing it in T-chart style again, just like Kaylee did. Alright, first we're going to talk about an equivalent fraction, which means it takes up the same area or space. Our first one will be 1/2 does equal 2/4. I'm going to demonstrate this with our fraction circles that we have in front of us. You guys can work along with me if you like, otherwise you can watch. These go all the way up to like 12ths, so be careful taking them out. There's a lot of pieces. First, we'll start with our pink semi-half. This is our 1/2. This is our first fraction. Now, we'll be finding our 1/4 pieces. Our fraction says we have 2/4 pieces. They're both yellow. We're going to lay them over to show that 1/2 equals 2/4 pieces because they take up the exact same area. There's no overlapping. There's no space that's left open, which means they are equivalent because they're taking up the same area. Cool, right? I know. Super cool. Our second example of an equivalent fraction is 1/4 equals 2/8. We're going to do that again with our little fraction circles. We're going to start with one of our 1/4 pieces. They're yellow. And we're finding our 1/8 pieces, which I believe are blue. Dark blue. I know, it's kind of messy. There's a lot of pieces. There's 51 pieces. I know. But to reiterate this again, an equivalent fraction has the same area or takes up the same space as the other fraction that it has. So if you lay your 2/8 pieces over your 1/4 piece, there isn't any space left over, which means that they are equivalent. Cool, right? I know. I love equivalent fractions. And wherever my mark. Now we're going to talk about an equivalent fraction that is not equivalent to the fraction it's being compared to, which is 1/12 is not equal to, this is the not equal sign, in case any of you guys don't know this. It's not equal to 1/2. And again, we'll come back to our fraction circles. Our 12th pieces are the black ones, and our half pieces are the pink ones. We're going to lay our 1/12 piece over our 1/2 piece, and it shows we have open space. We have a lot of pink left over. So our 1/12 doesn't take up as much space as 1/2, so they are not equivalent. Again, we have 1/3. is not equal to 4/3. And again, with our pieces, we can find our thirds pieces. We have a full circle plus an extra third that I don't have on me. So we have 4/3. We have a whole because 3/3 is 1 plus 1 extra third, which equals 4/3 pieces. And 1/3 does not equal 4/3 because it doesn't take up as much space. I have some more examples that are equivalent fractions. We talked about in our definition that it can be 2 or more fractions that are equivalent. So 1/3 is equal to 2/6, but it's also equal to 4/12. If you guys want to do it on your fraction pieces, you can. Otherwise, I'm just going to keep going, as I've done enough examples with our fraction pieces until I feel like we need to do another one. Next, in our not equivalent fractions column, we have the fraction 3/4 is not equal to 3/6. Even though these fractions both have a 3 in the numerator, does not mean that they are equivalent. That does not mean that they are equivalent because they don't take up the same space. We could have 3 1/4 pieces, and we can have 3 6th pieces, but 6ths are smaller, so they're not going to take up as much space, and we have the same amount of them, so if we have one that's bigger and has the same amount, that one will take up more space, meaning that they are not equivalent. On our equivalent side, we have 3/2 equals 6/4. This again is equivalent because they take up the same space. If you want to do it with your fraction pieces, you can. You don't have to. But I want to talk about these are both improper fractions, which means the number in the numerator is bigger than the number in the denominator. Does not matter. They can be equivalent. It doesn't matter which order your numbers are, if the bigger number is on top or the bigger number is on the bottom. We also have another example in our not equivalent fractions column, which is 3/2 is not equal to 2/3. Even though these have the same numbers used in our fractions, does not mean that they are equivalent. These have the same numbers used, but they're not in the same places. These pieces are bigger and there's more of them, and these pieces are smaller and there's less of them. So if you were to do it with your fraction circles, this one would take up more space than this one. Lastly, I have an example in our equivalent side, which is 3/3, which is equal to 4/4. 4/4 is also equal to 1. I'm going to do this one on our little fraction circles one more time, just to help you guys out. We have 3 of our orange pieces, which makes a whole. We have 4 of our yellow pieces, which make a whole. And we have 1 whole piece. All of these take up the same space. If you want to overlay them, you can, but you don't have to. You can just kind of look at it. They all take up the same area, even though some of them have more pieces than others. Cool, right? Next, we're going to start our true-false portion of our equivalent fraction stuff. So if you want to put your fraction circles away in the containers, that would be great. And we'll be getting into our whiteboards. 1 per each person, a marker, and an eraser. Thank you. Alright, your guys' job is I'm going to put some sort of equal or not equal fraction up on the board. Your job is to say if I'm saying is true or if it is false. You guys can, again, use your fraction circles, draw on your boards if you need to, ask questions, you can talk to the people around you. Our first one, there's only going to be 5 of these problems. Our first one is it true or false that 1/2 equals 6/12? True or false? You can write true or false on your board. If you want to draw pictures, you can. Otherwise, we'll just wait for everyone to have an answer. Alright, what do you guys think? Great job. You all said true, which is awesome. That's what I like to see. Alright, your next example is 3/6 is not equal to 3/4. Is this true or false? What do you guys think? Write it on your boards. If you need to draw again, you can draw again. Good job. You all said true, which is correct for this example. Your next one is 1/4. Oops. Is not equal to 2/8. Do you think this is true or false, the way I stated it on the board? Good job. You're right. It is false. 1/4 does equal 2/8 pieces. Our next example is 1/5 equals 2/10. Is this true or false, the way I've stated it on the board? Good job, guys. It is true. You all said the right answer. Our last example is 6/6 is not equal to 1. Do you guys think this is true or false, the way I've stated it on the board? Good job. It is false. 6/6 is equal to 1. Does anyone have any questions for me before we move on about equivalent fractions? Do we understand everything we're talking about so far? Perfect. Your next job is, I have a short little worksheet for you guys. I'm going to hand it out and then I'll talk about the directions. This is for you. This is for you. That's for you. Yeah. Alright, you guys can put your name on it. You can put the date. I think I put the date on there. Yeah, cool. I didn't. Cool. Alright, so your directions are for this. You'll be working individually, which means by yourself. You can use your fraction circles if you want to help come up with other fractions, because you'll be giving 2 examples of an equivalent fraction to my example of a fraction, and you'll explain how you know this. When you're done, you can flip your sheet over, put your pen on top, you can draw on the back, you can sit quietly, take a nap. Does not matter. Feel free to begin. If you have any questions, raise your hand. In your explain portion, you can feel free to draw pictures too, if you can't come up with the right words. job, guys. Alright, to finish our lesson up, you've finished your worksheets completely. We're going to talk about how to solve our problem from the beginning on how I'm going to ever make my friend's birthday cake for them. So, if I can find it. In our problem, it says that I have these measuring cups. I have a 1/8 cup, a 2/3 cup, and a 1/2 cup measuring cup. But my recipe calls for 1/4 cup, 4/6 cup, 5/10 cup. Can one of you guys tell me how I can use how many 1/8 cups it takes to make 1/4 cup for my recipe? Yes.
2.
Perfect. I will need times 2 to equal 1/4. Alright, for my second one, I have a 2/3 cup measuring cup, but my recipe calls for 4/6 cup. Can someone tell me how many 2/3 cups I need to get to 4/6 cup? Anyone? It's 2. I think, yeah. Alright, 1/2 cup and 5/10 cup. Can someone tell me how many 1/2 cup is equal to 5/10 cup? Just one? Good job. Alright, lastly, I wanted to ask you guys, what is your guys' favorite flavor of birthday cake? Anyone? Yeah? Kaylin?
Marble.
Atta girl. Lorelai?
Chocolate.
Skylar?
Banana.
Alright, that's the end of our lesson. Thank you guys for being maestros of equivalent fractions.